To retake the Journeyman Electrician exam in Massachusetts after failing it 3 or more times, the Massachusetts Board of State Examiners of Electricians requires that you meet current requirements. This generally means completing an approved electrical training program or demonstrating 4 years of documented electrical experience within the past 10 years. However, there is a grandfathering provision for electricians with substantial experience. If you've worked as an electrician for at least 10 years and can prove your knowledge through work history and references, you might be able to waive certain requirements, like formal electrical training. To find out if you qualify for grandfathering, contact the Massachusetts Board of State Examiners of Electricians. Provide them with documentation of your work experience and qualifications so they can review your application and determine your eligibility. Even if you are grandfathered, you will likely still need to pass a criminal background check and provide proof of insurance to retake the exam. Contact the Massachusetts Board of State Examiners of Electricians directly for the most accurate and up-to-date information. You can reach them at 617.727-9930 or visit their website to confirm the details of the requirements. It is important to always check with the official source as requirements can change. To best prepare for retaking the exam, consider the following points. Firstly, thoroughly review the National Electrical Code, or NEC. The NEC is the foundational standard for electrical installations, and a strong understanding of its articles and tables is crucial. Pay close attention to changes in the NEC since your previous attempts, as code revisions are frequent. Secondly, practice with sample questions and mock exams. These can help you identify areas where you need to improve your knowledge and test-taking skills. Several resources offer practice exams that simulate the actual Journeyman Electrician exam format. Thirdly, focus on areas where you struggled in previous exams. Analyze your past performance to determine which topics or types of questions gave you the most difficulty. Then, dedicate extra time to studying those areas. Fourthly, consider enrolling in a refresher course or study group. These resources can provide structured learning and peer support, helping you stay motivated and on track. Fifthly, familiarize yourself with the Massachusetts electrical regulations and amendments. The state may have specific requirements that supplement the NEC. These are important to note. Sixthly, ensure you have a solid understanding of electrical theory and calculations. These are essential for solving many exam questions. Seventhly, practice your time management skills. The exam is timed, so you need to be able to answer questions quickly and efficiently. Eighthly, get adequate rest and nutrition before the exam. Being well rested and nourished will help you stay focused and perform at your best. Ninthly, bring all required documentation and materials to the exam. Make sure you have your identification, pencils, calculator, and any other items specified by the testing center. Tenthly, read each question carefully before answering. Pay attention to keywords and avoid making assumptions. Each question should be analyzed completely before a response is selected. It is also worth noting that continuing education is important to keep up with the changing times. Continuing education ensures you are aware of the newest changes in the National Electrical Code, NEC, and it is also great for networking with other electricians. Furthermore, understanding circuit calculations is also very important. Ohm's law is a fundamental concept that relates voltage, current, and resistance in an electrical circuit. The formula is voltage equals current times resistance, or volts equals amps times ohms. For example, if a circuit has a resistance of 10 ohms and a current of 2 amps, the voltage is 20 volts. Power calculations are essential for determining the energy consumption of electrical devices and systems. Power is calculated as power equals voltage times current, or power in watts equals volts times amps. For example, if a device operates at 120 volts and draws 5 amps, the power consumption is 600 watts. In series circuits, the current is the same through all components, and the total resistance is the sum of individual resistances. The voltage is divided among the components. In parallel circuits, the voltage is the same across all branches, and the total current is the sum of individual branch currents. The reciprocal of the total resistance is the sum of the reciprocals of individual resistances. Understanding transformer principles is also an integral part of understanding how voltage levels are stepped up or stepped down for various applications. Transformers operate based on the principle of electromagnetic induction. A transformer consists of two or more coils of wire wound around a common core. The primary coil is connected to the source voltage, and the secondary coil provides the output voltage. The turns ratio of a transformer determines the voltage transformation ratio. The formula is voltage primary divided by voltage secondary equals turns primary divided by turns secondary. For example, if a transformer has a turns ratio of 101, the secondary voltage will be 1/10 of the primary voltage. Understanding grounding and bonding is essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. Bonding connects all metal parts of an electrical system to create an electrically continuous path, minimizing voltage differences and reducing the risk of shock. The grounding electrode conductor connects the grounding system to a grounding electrode, such as a ground rod or water pipe. Bonding jumpers connect metal parts of an electrical system to ensure electrical continuity. Another very important aspect is understanding overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from excessive current flow, which can cause overheating and fire. Circuit breakers are resettable devices that trip when the current exceeds a predetermined value. Fuses are one-time devices that melt and open the circuit when the current exceeds a predetermined value. The ampacity of a conductor is the maximum current it can carry continuously without exceeding its temperature rating. The size of the overcurrent protection device must be selected to protect the conductor from overcurrent. NEC Table 310.15b16 provides ampacity ratings for various types of conductors based on their size and insulation type. For example, a 12 American wire gauge, or AUG, copper conductor with type THHN insulation has an ampacity of 30 amps at 30 degrees Celsius. Knowing how to do voltage drop calculations is important for ensuring proper voltage levels at electrical equipment. Voltage drop is the reduction in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction. The formula for voltage drop is voltage drop equals 2 times K times I times D divided by circular mils, where K is the constant for the conductor material, I is the current in amps, D is the one-way distance in feet, and circular mils is the area of the conductor. The National Electrical Code, NEC, specifies the maximum allowable voltage drop for branch circuits and feeders. Another crucial aspect of being an electrician is knowing how to do conduit bending. Conduit bending is the process of shaping electrical conduit to route wiring around obstacles. Conduit benders are used to create bends of various angles. The take-up for a conduit bender is the amount of conduit that is consumed in the bending process. The gain for a conduit bend is the distance saved by making the bend. One must also have a thorough knowledge of electrical symbols. Electrical symbols are used to represent electrical components and devices on drawings and diagrams. Understanding electrical symbols is essential for interpreting electrical plans and troubleshooting electrical systems. Common electrical symbols include switches, outlets, lights, motors, and transformers. A key part of being a journeyman electrician is knowing how to do motor controls. Motor control circuits are used to start, stop, and control the speed and direction of electric motors. Motor starters are used to provide overload protection and disconnect means for motors. Variable frequency drives, or VFDs, are used to control the speed of AC motors. Understanding and using test equipment is critical for diagnosing electrical problems. Multimeters are used to measure voltage, current, and resistance. Clamp-on ammeters are used to measure current without breaking the circuit. Insulation testers, also known as megas, are used to measure the insulation resistance of conductors and equipment. Some other critical topics include the following. Firstly, safety procedures. Always follow safe work practices when working with electricity. This includes wearing personal protective equipment, PPE, such as safety glasses and gloves, and energizing circuits before working on them. Secondly, troubleshooting techniques. Develop systematic troubleshooting techniques to diagnose and repair electrical problems. This includes using test equipment, analyzing circuit diagrams, and consulting with experienced electricians. Thirdly, communication skills. Communicate effectively with customers, colleagues, and supervisors. This includes explaining technical concepts in a clear and concise manner and listening actively to understand their needs and concerns. Fourthly, business practices. Understand basic business practices such as estimating costs, writing contracts, and managing finances. This is especially important if you plan to start your own electrical contracting business. It is also important to remember that electrical codes and standards are constantly evolving. Stay up to date on the latest changes by attending continuing education courses and reading industry publications. The National Electrical Code (NEC) is revised every 3 years, and it is essential to be familiar with the latest edition. Remember that being a successful electrician requires a combination of technical knowledge, practical skills, and professional qualities. By continuously learning and improving, you can advance your career and provide valuable services to your community.